Okay, ada record. Okay. So most of the time the solvent is water. But sometimes they use different solvent lah. Okay. So everyone okay so far? What is solution? Solute plus solvent?
Okay.
Okay, good.
Okay.
So this is the thing that I say that you have to hafal. Oh, banyaknya peningnya, don't worry. So there's a technique untuk hafal. So we have five concentration measurement. Molarity, molality, mole fraction, percentage by mass, percentage by volume. Alright? Okay, so untuk molarity, molarity is one of the selalu yang kita guna. So molarity is usually kalau you guys nampak is dulu kalau you guys buat eksperimen dia macam cakap 0.6 mole molar HCl, which is dia punya concentration. Okay, and then we have molality, mole fraction, percentage by mass ni, and percentage by volume. Kalau you guys tengok you punya shampoo bottles or sometimes food, they don't give this percentage weight by weight. So this is what we are looking for lah. Okay, banyak, yes banyak, but you guys, one thing I can give you guys that untuk hafal this, you have to look at the units. Just tengok unit, you actually can hafal lah. So if you look untuk dua ni, unit dia percentage. So you know lah, kalau percentage by mass, mass over mass lah. Volume over volume. That's no problem. Okay. What you guys need to hafal, molarity, hafal dia punya unit. Okay. One thing, if you look at the unit, okay, it gives you a lot of information. Nampak tak? Mole, liter per. So maksudnya dicari adalah mole bahagi dengan anything is dalam bentuk liter. Okay, while molality, dia punya unit is mole per kilogram, which is mole bahagi dengan mass dia dalam bentuk kilogram. Okay, untuk mole fraction ni je yang you guys kena hafal lah. So mole fraction, apa yang kita nak cari tu mole dia bahagi dengan mole. Contohlah dalam solution tu ada mole A and mole B. So okay, itu je yang you guys pretty much kena hafal, these tiga, because these two is it is dah dalam nama dah. Kalau tanya percentage by mass, which is percentage, you akan kena 100. Kalau mass bahagi mass, and then volume bahagi volume. Okay, so everything is fine so far?
Yes, sir.
Okay, I'm going to look into each one lah. Okay, for example, molarity. Okay, also known as concentration. Some question dia cakap dia punya concentration. Okay, so calculate the molarity of 15 grams of potassium iodide in 50 milliliter of solution. So what you need to do is, okay, in any question, macam any question dari high 2 pun saya cakap, any question what you guys need to do is salin dulu dia punya formula. Remember dia punya formula. So molarity. Okay, we have two, molarity and molality. So kalau ada R ni is the one yang kita usually guna lah, dia punya concentration. So apa dia punya formula? So molarity. So molarity is equivalent to moles of solid. Okay, salin semua balik je. Over volume of solution. Volume of solution. Okay, kalau you guys tak ingat formula tak apa. Kan saya cakap tadi is ingat dia punya unit. So this mole per L kan. So maksudnya kita perlu tahu dia punya moles bahagi dengan dia punya solution punya volume lah. Okay, so apa yang kita ada? So dia ada 15 gram of potassium iodide in 50 ml of solution. So we have mass. So mass nak tukar ke moles, ingat tak saya tu macam mana? How does mass kita tukar ke moles? Mass ke moles?
Bahagi molar mass.
Yes. So one way you guys nak tulis the symbol for moles, we use N. It's like a small n. Okay. So kalau I tulis like the small n for Ki, alright, that means that the moles of potassium iodide. So it's equivalent to dia punya mass, macam kawan kita dah cakap tadi, bahagi dengan molar mass. So can you guys calculate? So can you guys find kalau apa molar mass untuk potassium and iodide? Okay, you guys can refer to the periodic table that I gave or the tutorial book where ada molar mass punya table tu. Alright, so potassium, how much? 39.098 plus iodine, how much? 1, 2, 6.905. Okay, can somebody calculate it for me? Tolong kira. Dapat tak jawapan? How much? Alright. Okay, dapat jawapan berapa?
0.09.
0. So it is 0. 9.
0.09.
0.09. So okay lah. So kita letak 3. It is moles, right? Mole, right? So now you have the first thing, and then we need to find the volume of solution. I mean, volume of solution. Remember dia punya unit, which is mole per liter, right? So molarity is equivalent to, kita dah tahu dia punya moles of solute, okay, 0.09 mole divided by volume of solution. So volume of solution dia dah bagi 50, okay, tapi remember tak, milliliter. So in physics you guys dah belajar ke belum nak tukar milliliter ke liter macam mana? Dah belajar ke belum this thing suffix dia call tera, giga, mega, kilo, desi, senti, mili, micro, nano, pico. Dah ingat ke? Dah kan? So kalau you guys tengok milliliter is 10 times to the power of negative 3 liter. So you guys boleh calculate, dapat jawapan tak? Because I tengah cari my calculator and I think my calculator is missing. So bear with me. Oh no, I found my calculator. Okay, tolong kira. Takkan semua saya nak kira.
1.8.
1.8.
1.8.
Okay, so it's 1.8. So molarity, you boleh, okay, molarity you boleh nak tulis macam ni. You nak tulis mole per liter. Okay, you can, absolutely can. But sometimes in book, what ditulis is 1.8 m. M, nampak tak? My the unit tu is also acceptable for molarity. So in question pun later you will see dia orang tak tulis mole per liter. The reason why I want you guys to remember mole per liter is so that you guys boleh ingat the actual formula. Alright, you guys boleh from the unit, SI unit, you boleh tengok formula. Nanti question dia orang akan bagi M. Absolutely, mostly kebanyakan dia orang akan guna M. Boleh? Boleh ke? Everyone is okay?
Boleh, sir. Yes.
Boleh.
Okay, good.
Boleh.
Next one. This is confusing because dia sama. So molality and molarity. So we have molarity and molality. Alright. So we have moles of solute over moles of solvent. Alright. Alright. If you look at this, okay, the only difference actually, molarity we use volume. Molality, L, kita guna mass. Okay, so it's actually the same thing. So tolong cari, okay, I nak you guys tolong cari dia punya moles of CH3COOH untuk acetic acid. Tolong cari, okay? Tolong cari how much, and then kita nak tengok macam mana kilogram. So molarity is equivalent to moles of mole of solute over mass of solvent. Alright. Okay, tolong cari moles. Tolong saya. Dah dapat ke?
0.5 mole.
Yes. So it is 0. Mana my cursor? Okay. 0.5 mole. Alright. So masukkan dalam you guys punya formula 0.5 mole over mass of solvent. So it is given 1.0 in grams. But kalau you guys tengok, the unit is mole per kilograms. So grams per kilograms. How much? Okay, kalau you guys remember, kalau dari kecil ke besar is
10 negatif 3.
yes. Kilo is negative 10 kuasa 3 kan. But since it is kecil ke besar is negative 3. I wouldn't go into further into this lah, because you guys should know this from you guys punya physics punya kelas. So now if you calculate, you should get 3.33 mole per kilograms. Okay. So usually kalau untuk molarity, usually kita akan guna SI unit lah. But sometimes they also give macam this. Look at this, small m. So you also guna 3.33 small m. So I tak suka you guys guna small m, because takut tulisan buruk ke, okay, apa ke, takut you guys tertulis 3.33 m besar. This dah masuk lain lah. This is dah masuk dia punya concentration yang tadi. Okay, boleh. So I'm gonna go to the next one. Mole fraction. Mole fraction is the last one yang you guys kena remember. Okay, I promise lah. Okay, mole fraction. Okay, macam mana nak jawab dia? So kita have by dissolving 32 grams of methanol in 72 mana my cursor Okay, in 72 grams of water. So you guys dah tahu ini kita have this and we have water. So calculate the mole fraction of methanol. So dia nak mole fraction methanol in the solution. So what you need to do, macam tadi, anything nak jawab question, remember dia punya formula, tulis dulu formula. So mole fraction of methanol CH3OH. Okay, so X denote that mole fraction, right? So should be equivalent of moles of CH3OH, okay, and total number of moles. So total number of moles maksudnya the moles of C3OH plus the number plus the moles of water. So what's the formula of water? Semua orang tahu. Okay, baby baru lahir pun sepatutnya dah tahu. So it is H2O, right? Okay. So the information that we need to find is the moles of CH3OH and the moles of water. So tolong cari OH. So that's why hari tu punya you guys have to master. Ingat tak perlulah nak buat stoichiometric comparison hari tu sebab untuk ke moles we have to divide, right? So please divide. Tolong cari jawapan. Quick.
0.2.
Dapat ke? So this you should have. So untuk methanol you should dapat 1.0 mole. While untuk water you should get 4.0 moles. Dapat ke? Dapat ke? Everyone
Dapat.
dapat?
Dapat.
Eh, mana begini? Okay, so should dapat. So this is quite simple where dia nak mole fraction of methanol. So mole fraction of methanol, berapa mole methanol per dengan the total number of moles. So you should dapat 1/5. Why dia tak ada unit? Kenapa tak ada unit?
Mole over mole.
More
Yes,
more.
correct.
Because we cancel the mole.
So this is mole, this is also mole. So what we do, we pangkahkan diorang. So mole over mole, tak ada unit. So this is your answer. Kalau lah, for example, you guys buat, nanti you jawab 1/5, you tulis mole, then this answer is incorrect. Your answer akan jadi salah. Okay, so remember unit is very important. Alright. So now percentage by mass is the one yang I cakap. You guys tak perlu hafal. Percentage by mass. So maksudnya mass bahagi mass. So one thing you guys, because I pun dulu I pening. So apa nak bahagi apa? Always remember, okay, solute over solution or solvent. Solution or solvent. Okay, benda yang penting atas ni is always solute. Okay, apa tu solute? Aduh, first time dengar ni, apa ni solute? So ingat, solute ni macam garam, gula, macam tu lah. Benda yang kita nak larutkan. Okay, ataupun Milo. Milo, pagi-pagi minum Milo. Itu adalah solute. Okay, solvent is dia punya air. Okay, contohnya air. Kita nak buat Milo, air kita punya solvent. Solution, okay, solution is the total air, so which is air Milo. Okay, so now kita tengok on percentage by mass. So dia bagi 0.8 mole of solution or sulfuric acid has the density of 1.1 gram per cm cube at room temperature. What is the concentration of this solution? Alamak, dia tak minta percentage by mass. Okay, why I give you example of this kind of question? Kebanyakan dalam question dia tak macam tadi. It's very straightforward. Terus tanya mole fraction. Most of it dia akan pusing because you guys dah matriculation level, dah one step nak masuk uni. You punya question you guys have to expect untuk dia tanya benda lain. So macam mana nak jawab ni? So the first thing yang you guys perlu buat, what I like you guys to buat is highlight the important bit. So you have mole per dm solution of sulfuric acid. Okay, dia ada density. Okay, room temperature maybe or maybe not, but take note. Okay, tolong tulis untuk room temperature. Apa yang you guys perlu take note is kalau dia ada gas volume. So dalam ni ada gas volume ke? Dia tak ada gas volume. So I don't need this information. So just cakap, nak bagi nampak panjang je. So the question is, what is the concentration of the solution? Okay, ini dah tolong bagi, right? So what you guys need to do? Alright. So pen, alright. So apa yang you guys need is, what is 0.8 mole per dm of solution? This is dia punya concentration tadi kan? Concentration, which is also you guys punya molarity. Right? So it is molarity. So and also have density. Anyone know that formula for density?
Mass over volume.
Yes.
Mass bagi volume.
Mass
volume.
volume. Alright. So what I like you guys to do is, dekat atas ni list all the formula yang you guys tahu berkaitan dengan the information. So now is you have the mole solution of sulfuric acid. So sulfuric acid is dia punya concentration tadi, molarity. Molarity is kita ada mole of solute over volume of we have tadi volume of solvent, right?
Solution. Solvent.
Betul kan? Solvent.
Solution.
Solution or
Solution.
solvent?
Solution.
Solution.
Right. We have the volume of solution. Okay, good. So, and then what's the concentration of this solution in weight percentage? So, dia cakap weight percentage. So, kita tengoklah percentage by mass is percentage by weight is equivalent to mass of, so we have mass of solute over mass of solution lah, actually pendek, times 100. Okay, this is how you generally nak answer any question yang susah. Okay, which is you list kind of everything yang you know, so and then now you can work through to find the solution. So dia nak is percentage weight by weight. So what you guys need is mass of solute and mass of solution, right? So macam mana nak cari ni? So the first thing is what you need to do, a lot of this kind of question, you know the technique untuk jawab. So what you guys need to do is you need to assume dulu dia punya volume of solution. So let's assume the H2SO, so sulfuric acid ni is H2SO4 lah. H2SO4. Okay. So let's assume H2SO4 punya volume is equivalent to 1 dm cube. Okay. So 1 dm cube ni is equivalent to what? 1 liter lah. Right. So now from this kita can find the mass of H2SO4. So kita boleh tengok mass of H2SO4 from, so mass of H2SO4 from the density. Okay. Kalau you tengok the density is mass of volume. So kalau untuk cari mass is density times volume, right? So density times, no, I'm sorry, okay. Untuk mass kita ada, I'm sorry. Kita tak guna density, okay. Untuk kita cari mass, we have dia punya molarity, right? So kalau daripada molarity, boleh tak kita cari mole and then kita cari mass? Boleh kan? So what you do, let's find dia punya mole dulu. So kita cari mole of H2SO4. Okay, the mole is, which is molarity times volume. So molarity is 0.8 mole dm cube times 1 dm. So 1 dm. So you cancel. Dia punya mole is 0.8 mole, right? Okay. So dari mole boleh tak dapat dia punya mass? So dia punya mass of H2SO4 should be equivalent untuk mole dia darab dengan molar mass kan? Untuk ke mole kita bagi, untuk keluar daripada mole kita darab. So which is 98 gram per mole. So you should dapat 78.4 gram. Okay, dapat ke? Okay, so now kita dah dapat mass of H2SO4, which is the solute. Kita dah dapat this, so we can check this. So now kita nak cari mass of solvent. So macam mana lah pula nak cari mass of solvent? So kita dah assume tadi dia punya H2SO4 ni, kita assume dia adalah 1 dm cube, which is equivalent of 1 liter lah. So from this, kita gunalah pula density dia, density yang dia bagi tu. So density is mass over volume, right? So untuk mass of solution, okay, you faham kan macam mana I dapat mass of solution is equal to the density times volume, right? Faham kan? Which is you guys pindah silang je. So mass, nak cari mass, so volume you pergi sana jadi darab kan. Okay, that's like sekolah menengah punya matematik. So mass of solution, we have the density, but this, okay, I want you guys to take note of the unit. Banyak of the question, they treat you like this, okay? So if you take a look, dia punya density is 1.10 gram cm cube, while kita punya volume tadi kita assume in 1 dm cube, right? 1 dm cube. Okay, one thing I want you guys to take note lah, you boleh nak assume dia punya volume tu any volume, okay? Doesn't have to be 1. Why I assume it 1? Because it's easy kan, so darab 1 dia dapat. And also I choose dm cube because untuk sini senang. Kalau I choose cm cube, I kena ubah dekat sini lah, sini senang. Since I already choose 1 dm cube, untuk darab ni it doesn't make sense kan, cm cube nak darab dm cube, so you have to change. So macam mana nak tukar, right? So dm cube, okay, I'll give you this lah. So dm cube is equivalent to liter, 1 liter. Alright, cm cube is equivalent to milliliter. Okay, how many milliliter in 1 liter?
1,000.
Berapa tu?
1,000.
1,000, right? That's correct, 1,000. So it is 1.10 gram per cm cube times 1,000 cm cube. So you cancel. So you should dapat 1,100 grams. Okay, boleh ke?
Boleh.
So, tapi ingat, tak habis lagi. Okay, tak habis lagi. We have 2. Allah Akbar. So, we have 2. The question tanya what is the concentration of this solution. That's why it is important for you to have highlighter. Okay, so you highlight, you know apa yang dia tanya. It is better, okay, untuk you highlight the information in different color. So, information maybe color kuning. Untuk soalan dia, you highlight dalam color hijau ke macam tu. So you know, hijau is what they want, kuning is the information. So I'll go to the next slide. So tolong ingat takut I lupa. So H2SO4 is 78.4. This one is 1,000. So dia nak concentration of this solution in weight percentage. So weight percentage is equivalent to dia punya solute, which is tadi kita H2SO4 kan. Is it 72.8? Berapa tadi?
8.4.
78.4, right? Ayah, jangan So it is 78.4 grams over 1,100 grams times 100, right? So you should dapat 7.13%. Then this is your punya final answer. Okay, percentage is very simple. You have to remember the unit is percent lah. I mean, it is, the clue is in the name. Dia nak percentage. Okay, weight percentage. Okay, Percentage mean it is per 100. So darab 100. So everything okay so far. This one.
Okay,
Yes.
sir. Okay.
Alright. Okay. If I'm going too fast, don't worry. You guys can ask me later because we have a lot of to catch up lah, basically. Okay. So now this is straightforward question. So what's the percentage required? Okay. Calculate the volume of antifreeze required to make 10 dm of solution antifreeze, which is 40% by volume. Okay, let's practice yang I cakap tadi. So you highlight the information in yellow to make. Oh my god, this is not yellow, so just pretend this is yellow. Okay. Okay. Okay, so we have 10 dm cube of solution and antifreeze, which is 40% by volume. Ayah, kenapalah dia merah? Okay, tak apalah. So and then the actual question is in green. So calculate the volume of antifreeze required. Alright. It tak semestinya dia punya question at the end sentence yang paling last. Sometimes it is at the awal-awal. So okay. So what I need you guys to remember, always do is tulis dia punya formula dulu. Percentage volume by volume is equivalent to volume of solute, okay, over volume of solution, okay, times 100. So apa yang dia dah bagi? Okay, dia cakap which is the percentage dah 40%. So kita dah ada this, and then dia cakap calculate the volume of antifreeze required to make 10 dm of a solution. Maksudnya volume of solution dah ada 10 dm. So dia nak cari ini, which is how much solute, okay, how much gula. Contohlah, okay, bayangkan how much gula yang you perlukan untuk buat air gula, yang di mana gula tu is 40% by volume. So this is very easy. What you guys need is masukkan saja, okay, volume of solute. Okay, this one is 10 dm cube and then times 100. So you should terus dapat of solute, dapat tak 4 dm cube? Dapat ke?
Dapat.
Dapat.
Alright. Okay, very nice. So just remember that we only have 5. Okay, untuk the bottom, just remember it is percentage. Okay, dia bahagi dengan total, which is solution lah. The one yang you guys have to remember is these 3 lah. Macam mana? Okay, so molarity very important. Sometimes diorang cakap it is as concentration. This one is rarely used, molarity, but sometimes diorang guna use juga. The only different, okay, you hafal satu, the other one you boleh hafal lah. You hafal molarity, which is mole per liter. Untuk molality, kita guna mass. So it is moles bahagi dengan mass of solvent. Okay, mole fraction, which is kita kena cari, kita nak mole yang kita nak bahagi dengan mole kita nak tambah dengan mole yang ada dalam. Alright, so everything is fine so far, because I want to masuk the next subtopic. So we want to masuk stoichiometry. So stoichiometry ni nanti yang kalau hari tu kita dah buat stoichiometric comparison. Alright, but now kita akan tengok, macam hari tu kan kita tengok macam mana chemist do cook, okay, the recipe. So this is the bread and butter of a chemistry punya recipe. Okay, the first thing you need to know is oxidation number. Okay, you guys actually dah pernah jumpa. Okay, so we have Okay, I'll give you 3 rules yang untuk know the oxidation number. Sekolah menengah pun you guys dah pernah jumpa. Alright. So first rule is in free element atoms or molecule, the oxidation number is 0. For an example, okay, oxygen gas. Oxygen gas, dia punya molecular formula is O2. Okay. So O2, okay, is an molecule. Okay, molecule. So dia punya oxidation, kalau based on this rule, it is 0. Okay. So this is tempat yang kita akan tulis oxidation number lah. But usually kita takkan tulis lah kalau 0. Kita just tulis macam tu je lah. So maybe carbon. Okay. Carbon. So carbon is also an atom. So dia punya oxidation number is, okay, oxidation number dia apa?
Kosong.
Yes, very good. So kalau I give you potassium, oxidation number dia should be 0 juga kan? Because it is element. Or it doesn't matter is atom or molecule. Okay, kalau lah dia, kita for example kita tengok itu vinegar, CH3COOH. Okay, you nampak dia tak ada charge. Okay, tak ada apa-apa ditulis kat atas ni. Okay, it means that the oxidation number of the whole molecule is 0. Okay, the oxidation number of this whole is 0. Alright, so now let's look for the monoatomic ion. Okay, the oxidation number is equal to the charge of the ion. So apa maksud dia? Contohnya sulfate ion, SO4 2 minus. So oxidation number for the SO4 ion ni is the oxidation number
-2.
Yes. Okay, oxidation number usually kita akan tulis -2. Tapi kalau dekat the notation, okay, SO4 kita akan tulis 2 minus. Okay, minus dekat belakang. Okay, don't ask me why, but people write it that way. Alright. So okay, tadi oxygen gas tadi bentuk dia macam ni, and then suddenly dia orang bergaduh, dia orang bercerai. So dia orang bercerai, tinggallah oxygen 2 minus. This is oxygen ion. So what is the oxidation number of oxygen ion?
-2.
Okay, equal to 2 minus. Alright. So okay. So everyone is clear? Let's go. For polyatomic ion, atoms, molecule, the sum of the oxidation number is equal to 0 to its charge. Right? So how about we look on this? Okay. Tadi we have H2SO4. Alright. This is sulfuric acid. Okay. Sulfuric acid. Okay. So dia cakap untuk dia punya untuk each, contohlah sometimes dia akan tanya what is the oxidation number of the maybe SO4 punya ions, dia punya species lah. So macam mana nak cari? We know that since it is a neutral atom, a neutral molecule, the oxidation number tadi awal-awal rule number 1 means the oxidation number is 0. Okay, it's equal 0. Alright. So macam mana nak cari? So it means that the total is 0. Okay. Cara nak cari dia, contohlah dia nak cari SO4, right? So kita nak tahu this. So this is one yang maybe you guys have to remember lah. Hydrogen is always, most of the time is +1. Oxygen is most of the time is -1. Group 17. Kalau you guys tengok periodic table, yang belah kanan sebaris sebelum yang paling kanan, which is most of it is -1. So cara dia, kita tahu kita ada 2 hydrogen and it is both +1. So kita ada +1 and kita ada 2 hydrogen which is 2 plus SO4 ni kita tak tahu kan, so kita denote lah maybe dengan X or Y or Z or whatever you want. So X So you buat the calculation, which is X equal to -2. So maksudnya the oxidation for SO4, the oxidation is 2 minus. Okay, boleh dapat? Okay, boleh tak kalau you guys buat Al2O3. Okay, cuba cari oxidation number of the aluminium. What's the oxidation number of aluminium? Of aluminium. Okay.
3.
Yes, dulu sekolah rendah you guys ada belajar kan? Darat silang tu. Okay. That one is okay, but sometimes more complicated atomic molecules susah nak buat, right? So macam sama, the total is 0. Aluminium you tak tahu tapi ada 2, right? Okay, untuk oksigen you ada 3, so tambah so oksigen which is -2, you darab 3. So X nanti you akan dapat plus 3. Dah. Okay. Okay ke? Oxidation number. So
Okay.
mostly
Okay.
dia punya charge.
Okay.
So I'm gonna I don't think I have time, but later probably I'll record a video that pasal chemical equation. So chemical equation is our recipe as a chemist. So it is a method of denoting chemical reaction using the symbol or formula. Okay, let's see. Okay, kita nak tengok that what is it? Hand sanitizer is actually flammable. Okay, you guys tahu tak? Yang you guys letak kat tangan korang tu is actually flammable, and there are cases that orang dah terbakar. Okay, let's look on the cases first. So kalau siapa yang geli nak tengok ni, look away, but you guys can choose to look away.
This mom suffered horrific
this
burns
girl-
to her face,
So
hands,
what-
legs, and stomach
Kalau you
after her
maybe
hand
tak dengar.
sanitizer.
So
Yes,
what
her
happened to this
hand
girl is
sanitizer
dia punya
set her
hand
on
sanitizer.
fire.
I'm in a lot of pain.
And then
Your whole
she
body.
went on
Excruciating.
straight
Sanitizer.
Gold
cooking.
bottle.
So
And I
what
just remember
happened?
them screaming
the
and
hand
saying,
sanitizer
"Mom's on
caught
fire! Mom's on fire!"
Katie
and
ignored her
burned
grievous
her
injury.
skin off. Okay, nampak tak?
Assistant fire
source of ignition because
Kenapa
Fire, mom's on
hand
brand
sanitizer
ensure
is
that you're away from
flammable?
any open flames. So you want to be
Because
away from the stove, you want to be away from
hand
candles,
sanitizer, we have
fire
alcohol,
pits, barbecues, anything that emits an open flame.
Okay.
I'm just
So it's
extremely
nothing
like.
important. Let's see. Okay. So, chemical equation for hand sanitizer. The combustion of hand sanitizer. Hand sanitizer terbakar. Most hand sanitizer use isopropyl alcohol. So, diorang akan tulis macam ni. Okay, banyak-banyak peni-peni ni is just to say that hand sanitizer terbakar. So, apa yang nombor ni? Kalau you guys tengok, we have reactants and we have products. So, apa yang kita guna, okay, bahan-bahan yang kita guna untuk memasak is called reactants. Kita letak sebelah kiri, always sebelah kiri, remember? And sebelah kanan is kita letak produk. Produk tu apa yang kita buat. So, kita letak bawang, kita letak telur, kita dapat telur dadah. Faham? And then the number here. Okay. So maksudnya apa ni? Stoichiometric coefficient. Stoichiometric coefficient is, for example, you guna 2 bawang, 9 biji telur, you dapat 6 biji telur dadah, tambah dengan 8 ni maybe kerak-kerak lah, maybe yang lebih-lebih tu. Okay. Faham? Okay. And this number, okay, make sure it is written very big, same size as the element. Okay, berbeza dengan nombor kecil yang I tulis kecil ni. This nombor kecil ni, it means that oksigen ada 2. Ada oksigen, ada 2. This nombor salah, ada 2. 9 maksudnya kita ada 9 moles of oksigen yang ada 2 ni. Okay, boleh faham? Okay, boleh faham. So now, okay, one thing to note, untuk anything yang we need to do, we need to have a balanced equation. Okay, what do you mean by balanced equation? That's the reason ada stoichiometric coefficient ni. Kenapa dia ada 2, 9, 6, 8 ni. Because kalau tak balance, it doesn't make sense. So what means by balance is, okay, the amount of carbon yang ada sebelah kiri sama dengan amount of carbon ada sebelah kanan. Okay, how does it make sense? Alright. Okay, so C3 6. Okay, kalau you guys tengok, carbon ada 3 kan? So ada 3 carbon, and then kita darab dengan 2, which is kita ada 6 carbon. While belah kanan kita darabkan 6 dengan carbon ni, so dapat 6 carbon. 6 carbon. So does it make sense? Kiri and kanan, any atoms must have the same exact number. So kalau sebelah sini, okay, oksigen kita ada 1 kan? Kita darab dengan 2. Kalau 2 ni ibarat dengan didarab dengan semua jangan depan saja. So oksigen pun darab 2, kita ada 2 oksigen sini. Sini we have 9 darab 2 18 oksigen. So berapa total oksigen ni? So it is 20 kan? 20 oksigen kan belah sini? 20 oksigen. So belah kanan also have to have 20 oksigen. So 6 darab 2 which is 12 oksigen tambah dengan 8. So 8 oksigen, right? So the total also 20 oksigen. So in a balanced equation, every single atoms have the same amount kiri and kanan. So bayangkan like a seesaw, alright? So okay, everything is faham pasal chemical equation?
Yes.
Okay, good. So I actually want to go through this. So we have two methods untuk balancing equation. Satu is inspection method, is very easy. Most of the time we do this lah kalau dalam question. This ion electron method ni we only do for redox reaction. There's step yang nanti I akan buat a video hopefully soon and I akan upload it lah. So in redox reaction where kalau dia bagi tahu that's the chemical reaction happens in redox, then kita akan guna ni. Kalau dia tak bagi tahu, kita akan usually guna inspection methods. Alright. Okay. So untuk inspection methods, okay, kita tulis. So the first step is kita tulis dulu apa dia punya reaction. Doesn't matter dia balance ke tak balance, kita tulis je. Second is kita balance other atom except H and O, and then kita check. Okay, let's do the practice. Alright. So how to balance this? Alright. The first thing you try to pick a number, not a number, an atom lah. So you guys nak pick yang mana dulu? Okay, how about kita pick hydrogen. So let's look at hydrogen. Okay, so hydrogen, so belah kiri ada 2 hydrogen, right? Hydrogen ada 2, so ada 2 hydrogen. Belah kanan ada 2 hydrogen. So is it balanced? Dah balance kan?
Balance.
So it is dah
Yes.
So far kita tinggalkan dulu. Alright. So now let's look on oxygen. So belah kiri kita ada 2 oxygens. Belah kanan we have 1 dari sini. So 1 tambah dengan 2. So have 3 oxygen. Oh my god. So apa kita nak buat? So what you should do is darabkan bahagian yang rendah. So maksudnya bahagian yang kurang oksigen kita darabkan. So what you guys need to do is cuba dulu buat dekat sini untuk balancekan dulu. So kita darabkan 3 dulu So kita darabkan 3. So it means now oksigen ada 3. 3 darab 2. So kita ada berapa? 6 oksigen kan? So now the new one we have 6 oxygen and then we have 6 hydrogen. Okay. Sekarang alamak, kita dah tambah sini lah pula kurang. So macam mana awak nak buatkan bagi ini jadi sama balik? Okay, macam mana nak samakan balik?
Times 3 times 2. 8 times 2.
Cuba korang fikir.
Darab 4, 2.
Okay, darab 4 depan ni kan?
Ya.
So, kalau ini darab 4, you dapat this is the berapa? Ini dapat 4, 6. So, oksigen dah 6. Tapi hidrogen pula ada 8.
Yang sebelah.
Hidrogen. Okay, do you have any more ideas kalau kita nak buat?
Bahagian kiri darab 4.
What if instead of darab 4, okay, kalau kita darab kat sini boleh tak? Okay, how about kita tambah 3 sini. So, jejak. I'm sorry that I pun pening sekarang. So, tolong, so let's do it with me. Kita tengok how kita nak balance that both side. Okay, this is our original punya ni. Kita ada 2 hydrogen sini, kita ada 2 oksigen sini. We have 2 oksigen sini, kita have 3 oksigen sini. So, kita nak, so the problem is oksigen sini kurang kan? So, let's darab sini. Kita, for example, kita darab 2 dulu. So, now we have, so ini, no, I'm sorry. So, ini 6 kan? So, kita darab 3 dulu. So, we have 6. So, 2 kita ada 8. 6 dah, oksigen dah betul. So, the problem now is hydrogen pula kita tak balance. Okay. And then, so what we need to do is, how about kita balance the oxygen guna here. Alright. So, this oxygen, kita darab, how about, because it will be even, right? Can anyone help me?
4 H2O2 equal to 4 H2O plus 2 O2.
Okay, 8 H2O2 equal to 4 H2O plus O2. Okay.
Depan
Berapa?
4 H2O2.
Okay, 4 H2O2, right? Betul kan? Okay. So, let's calculate lagi. So, 8. So, this one, kita ada 8 darab 2, 16 kan? So, 16.
Depan tu 4, sir.
Depan apa?
8 tu 4. Bukan 8, 4.
Here. Alright. So, let's do 8 hydrogen. So, and then oxygen pun ada 8. Right? So, on this side, so 4 darab 2, which is
8.
8 hydrogen. So 4 darab 2, so we have 4 hydrogen dapat 6 oksigen, right?
Lepas tu oksigen belakang tu darab 2.
Alright, yes, correct. So if you guys see like this, it is quite tricky untuk you guys buat one, like for example kalau I cakap, okay, this kind of this, you guys, okay, tambah sini 3, tambah 2, tambah 4. There's you have to do a lot of exercise untuk get this into your rhythm. Okay. Kalau ini pun nampak dah lebih, tak apa. This question, I will get back to you later. Okay. Yeah.
Actually, both side boleh darab dengan 2.
The simplest number is 2.
How about this?
Yes, 2H2O equal to 2H2O.
Okay, let's see
Yes.
this. Okay, so 2H2O2. So 2H. Sekejap So 2H2O2
We divide by 2, sir.
dapat 2H2O plus 2O2. Alright, so this one ada
Plus O2 je sir.
2. The oxygen is only
Plus O2 je.
Oxygen only O2.
so you got 4H, 4 oxygen, and then this one ada 2 darab 2, so you got 4H, so 2 plus 0, so you got 2 oxygen here and you got 2 oxygen here, which is 4 oxygen. Alright, okay, faham tak? So what you guys need to do is do a lot of exercises, and this is I cannot say there's a schematic untuk cara nak jawab inspection method nak balancing. You have to try and error. Look, macam tadi kita start dengan 3, okay, or maybe kita buat 3 tak dapat, we try 2, okay, now 2 dapat. Okay, this is macam ibarat you guys punya mathematics trigonometry. You have to do a lot of exercises untuk know the answer. Alright, okay, boleh ke? So the thing is, the balance, you have to make sure that kiri and kanan betul. So I think kita dah habis. So try to buat this question pula, and then we'll get back untuk next week. No, next week, no, this Thursday. Okay, buat this question. Okay, this Thursday, what I want is for you to so the tutorial question yang mana you guys tak faham, send the question first dekat I, so that I stop recording